Good morning, fifth graders. I want to start by sharing a little story with you. And before you think you maybe have clicked onto the wrong class, stay with me. There's a purpose for my reading of Goldilocks and the Three Bears. I probably won't read the whole thing because I'm guessing most of you know this tale. Once there was a little girl called Goldilocks. What a sweet child, said someone new in town. That's what you think, said a neighbor. One morning, Goldilocks' mother sent her to buy muffins in the next village. You must promise not to take the shortcut through the forest. She said, I've heard bears live there. I promise, said Goldilocks. But to tell the truth, Goldilocks was one of those naughty little girls who do exactly as they please. This is kind of like a little unconventional tale of Goldilocks. You can see her trying to make some decisions to go into the forest. Meanwhile, in a clearing deeper inside the forest, in a charming house all their own, a family of brown bears was sitting down to breakfast. The bears left, and a few minutes later, Goldilocks arrived at the bears' house. She walked right in, without even bothering to knock. On the dining room table were three inviting bowls of porridge. I don't mind if I do, said Goldilocks, helping herself to the biggest bowl. And we know how the story goes, right? Blech! That is too hot, cried Goldilocks, and she spat it out. Next, she tasted the porridge in the medium-sized bowl, but that was too cold. Then Goldilocks tasted the porridge in the little bowl, and it was just right, neither too hot nor too cold. In fact, she liked it so much, she gobbled it all up. And then what does she do next? Yes, so she is tired. She has a few different chairs. There's one that's too big, too small, and then wouldn't you know that Goldilocks finds one that's just right. And then she's really tired, so she decides to sleep. And I'm just kind of skipping through the pages here. And of course, there's a bed that's maybe too stiff, too soft, and then one that is just right. So you might be wondering what on earth Goldilocks has to do with science today. I'm going to let you think about that for a little bit as I play our very beginning part of the mystery. So as you're listening, maybe think, why did this teacher just read us this ridiculous children's story?
Hi, it's Doug. Let me tell you a true story. Halloween, 1938. At first, it was a night like any other Halloween in the United States. Children went out trick-or-treating, and after they came home, many families sat down, as they did every night, to listen to their favorite shows on this. Now, you see, back then, there were no television or computer screens. Those hadn't been invented yet. But there was radio. And as some people tuned in to their usual evening radio programs, suddenly they became very startled. What they heard was someone screaming on the radio, "Martians are landing! They're attacking!" As people heard this, many of them began to call their local police departments. Is it true? Are we really under attack by aliens from the planet Mars? We weren't under attack, as you might have guessed. What they'd been listening to was a reading of a fictional book, The War of the Worlds, written by the author H.G. Wells. The way it had been written, when read over the radio, sounded like a news broadcast. And that's why some people took it seriously and got worried. It wasn't intended to fool people, and not everyone was fooled. But enough people were worried that this gives you a sense of what people used to think we might find when we explore places in our solar system. Places like Mars, the moon, and more. You see, back in those times, no human being had yet been to space. In fact, we hadn't sent anything into space yet. Our only knowledge of the planets depended entirely on what we could see through a telescope. And that left room for a lot of guessing. Take Mars, for example, the red planet. Through a telescope, it looked a little blurry, but it seemed to have dark markings on its surface. No one really knew what to make of these. One astronomer wrote books and argued that these might be some kind of canals, or even tunnels, constructed by intelligent Martians. Some people even published maps and named these. And it wasn't just Mars that people imagined things like this. For example, some people imagine that the planet Venus, since it's closer to the sun than we are, might be a tropical paradise. Imagine an entire planet filled with jungle plants and warm beaches, even strange creatures. Maybe we could go live there one day. These days, though, we don't have to try to imagine what these places look like. Not only do we have rockets capable of sending things to space, we've actually sent robotic cameras to get close-up photos of every major planet in our solar system. We've even landed robotic cameras on Venus, Mars, and one of the moons of Saturn. We've discovered amazing things. Things like the yellow skies of Mars, oceans made of flammable liquid on Saturn's moon Titan, an entire moon of Jupiter that's covered in ice, a volcano on Mars that's 3 times taller than the tallest mountain on Earth. And while it's been incredible exploring the planets and getting to see what they're really like, it's definitely not what most people expected. What people might have thought were Martian canals turned out to be simply dark features in the rock. If there ever were life on Mars, it's not there anymore, and there's no sign of it. Mars is one big, freezing cold desert made of rock and sand. In most places on Mars, daytime temperatures rarely get above minus 80 degrees. Even Antarctica gets warmer than Mars. And Venus? It's no tropical paradise. Far from it. Robotic cameras sent there by Russia all melted within a few hours of landing on the surface of Venus. The temperature on the surface reaches nearly 900 degrees. That's twice as hot as a kitchen oven. As I mentioned, all of these images have been taken by robotic cameras that we've sent to these planets. They're controlled by remote control from people here on Earth. So far, the only place we human beings have actually visited, besides the Earth, is the moon. But if we ever were to travel to other planets and visit in person, it's clear that we would have to take a lot of precautions. Mars, Venus, any of the planets or moons, they all have conditions that don't make it easy for us to go visit. They're not exactly places that are habitable, good enough to live on. Based on what you know about the places in our solar system, would you visit any of these places? Where would you go? And what kinds of dangers would you have to protect yourself from?
So I think traveling to space would be terrifying, but a really cool opportunity. Would you ever visit places out in space? Would you limit yourself to places close by, like the moon or Venus or Mercury? Or would you care to venture off further? We know the dangers that we would need to face, such as extreme heat, extreme cold, intense gravity. So, I'm sorry, guys, there's construction in the classroom next door, if you can hear that. So there's all sorts of things that we need to protect ourselves, which makes Earth the most ideal place to live.
As we've explored our own solar system, we've discovered amazing things. But all of these places have turned out to be much more challenging places to visit than we ever imagined. None of the planets in our solar system have the same atmosphere that we have here on Earth. Mars and Venus's atmospheres are mostly carbon dioxide, almost no oxygen. Jupiter, Saturn, and the other gas planets don't even have a solid place to land. There's no surface, just colorful swirling clouds of gas. Visiting these places ourselves in person wouldn't be impossible, but we'd have to take a lot of precautions. We'd need special suits to protect ourselves from intense heat or intense cold. We'd have to bring oxygen to breathe, and we'd have to make sure there's water. There's no place in our solar system quite like home. Earth is unique. But are there planets other than the ones going around our sun? Like planets somewhere else in our universe? Planets not in our solar system? This is something that people have wondered about for a long time. As we look up at the night sky, we see hundreds of stars. Through a telescope, we see even more, thousands upon thousands of stars, all around us in every direction. As we've learned more and more about these stars, we've come to realize that our sun itself is one of these stars. It just happens to be the star closest to us. If our star, the sun, has planets going around it, couldn't other stars too? It's tempting to think, well, just point a really big telescope at each star and look to see if there's planets. The problem is, it's just not that easy. Each star is so far away from us that even if there were planets going around it, even the biggest telescopes aren't big enough to directly see any planets going around another star. All of that changed, though, starting in the 1990s. A few scientists came up with some really clever ways to detect a planet going around another star without actually seeing it. Now, the details of these techniques they use are complicated. It doesn't matter too much. But if you're curious, one method they use involves carefully measuring a star's brightness, and then noticing if the star's brightness dims ever so slightly. Basically, an eclipse. By using this and other techniques, scientists have been able to actually discover the first planets orbiting stars other than our sun, what we call exoplanets, planets that are outside our own solar system. At first, these techniques only worked for finding really huge planets around other stars, planets as big or bigger than Jupiter. But over time, as the technology has gotten better, scientists have discovered smaller planets too, ones that are Earth-sized. We've now realized that there are entire solar systems of other planets going around all kinds of stars. As of 2018, more than 4,000 exoplanets have now been discovered. And what's most exciting of all, dozens of these planets are a similar size and maybe even similar temperature as the Earth. What kinds of things will we find if we visit these planets? Alien life? Even if it's not intelligent aliens, could there be alien plants? Alien animals? And what if some of these planets were even places that we ourselves could live? Given that there are so many of these exoplanets being discovered, how should we decide which planets are the best choice to visit first? What do you think?
So if I were to decide which exoplanet to visit first, I would make sure that it has temperatures that could sustain life. I would make sure that there was something for me to eat and to drink, that I got enough light, and it wasn't too dark. What about you? What would be on your priority list? Okay, so we're not going to do the activity, but I am going to do parts of it with you. So I would like for you to um, just hold on for one moment while I pull up another presentation for you. Okay, so here we are, Mystery Lesson 8. Could there be life on other planets? And so we started the lesson off with reading the Goldilocks story. And maybe you have wondered why I started with that story. So if you were guessing that sometimes planets have to be just right in order for humans to live there, you're correct. So planets can't be too hot, they can't be too cold. They have to have very certain things in order for humans or plants to live there. Um, so what does a planet need to be habitable? And I want to start with the word habitable, meaning like habitat, so somewhere you can live. And not just humans, we need to think about our plant life as well. So what does a planet need for you to be able to live there? Well, the most important thing is light. And we need light so that planets can, one, maintain correct temperatures, but also plants need light to grow. And as you know, that humans rely on plants to live. So it can't be too far from the sun because otherwise it would get too much sunlight. And it can't be too far from the sun because then it wouldn't get enough. So I want to show you an image on the next page. Let me see if I can move myself over here. This is a fake planet called Theia, and there are 8 planets in Theia, just like our solar system. And they're shaded differently, and I'll talk a little bit about what that shading means. So basically, this is showing us that there's a level of light that each of these planets are receiving. So over here with the dark black background, they're receiving somewhere between 0 and 30% sunlight. So of the sunlight, and it makes sense, right? Because they're farthest from the sun. The dark gray, they're receiving between 30 and 60% of our sunlight. The next medium gray, 60 to 90% of the sunlight, and then 90 to 120 and 120 to 150. Down below on the slide, you can see that plants need more than 60% light. So what is the number that's greater than 60? Okay, so maybe 61, maybe 81, maybe 91. But they cannot receive more than 120% light to survive. So when we look at our planet decoder, which planets are in the range from 60% to 120%? Okay, so that means that this planet in the light gray and the planet in that whitish gray, it looks very white on the screen, so I apologize for that. That means there are only 4 planets on this, so in this solar system that you could live on. The first one receives too much sunlight. The second one, third one, fourth one, and fifth one receive between 60 and 120% sunlight. The other planets, the last 3 in the solar system, do not receive enough sunlight. So therefore, they would not be habitable. There would be not enough light or too much light. The next slide, we know that we need water. And water is kind of a unique thing because water can exist as a gas, water vapor, solid water, which we know is ice, and liquid water, which is what we would just call water. Is liquid water the most beneficial to us? Yes, because plants can't, if water is permanently frozen, plants can't access the ice because it's ice. If it's water vapor, plants and animals would not be able to use that as well. So what do you know about water and how it moves or transforms into ice, how it changes its state? And the temperature, right? So if a planet is super close to the sun, it's going to evaporate. It would have no liquid water. If it's too far from the sun, it would be ice, and ice would not be beneficial for life on a different planet. So if you don't know, on the wrong slide here. If you don't know that water freezes at 0 degrees Celsius, which is also 32 degrees Fahrenheit. So in the winter, when our lakes start freezing, that means the temperature is below freezing, below 32 degrees Fahrenheit or 0 degrees Celsius. Water boils at 212 degrees Fahrenheit, which is 100 degrees Celsius. So our temperatures have to be between those two. If it's anything lower, our water will freeze. If it's anything higher, the water will evaporate. So if we look at our decoder, we see that the planets that are in the dark black, too cold, we'd have frozen water. Anything that's in the whitish or very, very light gray, too hot, that water would evaporate. So our habitable planets, the ones we could live on, would be any of these planets that are in the medium gray and the dark gray, because their temperatures are sufficient enough to have water in the liquid state. So that means there are 3 planets. We don't want to count that little one because part of it is in the below freezing zone. So this is what we would call the Goldilocks zone, which is where that story comes back to us. It is the just right zone for us to live on, or plants. So the Goldilocks zone has to be just right amount of sunlight, just amount of right of water. And the sunlight, affects the temperature and how our plants grow. So when we think about this, we want to find a planet. There's lots of exoplanets, but if they notice they're too far from the sun, they're likely able to guess that they don't have any liquid water and that they don't have enough light to sustain life. I want to wrap up with one more thing, so just sit tight.
Everything we did was...
So I know we didn't do the activity, but I copy and pasted some of the images from the activity. So I'm going to play the very first part so you can see a little bit of a summary of what the activity was.
In the activity, everything we did was just hypothetical. The different solar systems we looked at aren't real places, but instead just ideas we used to think about what kinds of conditions real planets might have. But there are real solar systems out there. We're discovering new ones every day. What would it be like to actually go on a journey and visit one? First of all, imagine as we left Earth. The farther and farther away we get from our own solar system, the sun appears to get smaller and dimmer. As we keep traveling, eventually it becomes difficult to even tell our sun apart from all the other stars. It appears as just another star among the thousands of stars in our local part of our galaxy. But what would it be like once we arrived at another solar system? Take, for example, a real-life solar system, one only discovered fairly recently by a team of scientists. It's called the TRAPPIST system. And right away, you notice some really weird differences with our own solar system. For one, the star at the center of the TRAPPIST solar system is a very different star than our sun. It's smaller, and it's dimmer too. Even the color of its light is different. It gives off a reddish-orange light. So the view from one of the planets in the TRAPPIST system would seem very alien to us. But maybe the biggest difference of all is this. The TRAPPIST system contains several rocky planets, all orbiting closely to their star. Even though the TRAPPIST star is dimmer and cooler than our sun, these planets orbit closely enough that they're not too hot and not too cold. The temperature is just right for there to be liquid water on their surfaces. And they receive just enough light that plants might be able to grow and do well there. This zone, where the temperature and light are just right for the survival of life as we know it, is what scientists sometimes call the Goldilocks zone, as in Goldilocks and the Three Bears, the story where Goldilocks goes into the bear's house and tries different things that belong to the bears, like the 3 bowls of porridge. One is too hot, one is too cold, and one is just right. What would we find if we one day traveled to the TRAPPIST system and actually landed on one of the planets in its Goldilocks zone? Just imagine if one of the planets actually made a good place to live. Say that it was nice and warm and even had oxygen to breathe. What kind of view would you wake up to each morning? What color would the sky be, and what would you see? And all of this is just considering us living on one of these planets. But what if, when we land, there's already life growing and surviving on that planet? Obviously, it would be completely amazing if we were to ever find intelligent life, beings that we could communicate with and learn from. But even if we didn't find intelligent alien life, just any kind of alien life at all could be incredible to see. Could there be alien trees? Alien flowers? Alien insects? What kinds of alien life might we find? Nobody knows. And at least for now, it's anyone's guess. We can let our imaginations run wild. I'll leave you with this to think about. Maybe one day in the distant future, you'll be present when we make the journey to one of these faraway planets. Have fun and stay curious.
Okay, I hope you enjoyed that. And it's kind of a really bizarre thought to think that there could be other planets that are habitable or life on other planets. So imagine what that would be like if we were able to travel there. Bye, guys.